All right, we are looking at section 7.3, which are looking at proving triangles similar. So we've done something similar to this in the past, and we're looking at different theorems and postulates. All right, so here's the angle, which means we have two consecutive angles, letting us know. It's because if we have two that are congruent, then we know that the third has to be congruent. Another one that here's an example of that. We'll see others like this, where we have vertical angles, or we see where these cross at S, these angles have to be congruent to each other. And then we see that we're given a second angle. And then here are others where we're given the angles. Or we're given angles at which we can figure out the third angle by adding them and subtracting from 180. So we'll see a couple examples of those as we go through it. Also, the other is side, angle side. And so the sides that are congruent to each other, they make the angle that is congruent to each other. So we can kind of see how those things formed a vertex at the congruent angle. And then our last one is side, 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 probably the easiest one that we'll look at today. And so in this first problem, we're looking at, how is this similar? And so we're given here with the vertical angles, like we talked about. And then we have these. So we're given that this is 90. So if we know that these two are, if we add 50 and 40 up to 90, that means that this third angle also has to be 90. So this is where we get the angle. And here, if we're looking at this, we're given that this angle is, so that's where we get that middle part, the angle, and the two sides, they form, we have the same. So if we divide 20 by 16, and if we divide 15 by 12, we get the same number, things that we talked about before about having that scalar factor. Here, very similar to what I just talked about, they have kind of a triangle and another one inside it. And so if we look at the smaller plus the smaller, we get the larger, so 39. And we put those as ratios, and we see that they have the same number. So that's what's happening here with those sides and the angle. Because of the symmetric property, S is congruent to S is what's happening here. So that's how we get side, angle, and side. And here, just like the last problem, if we add those two sides, we should get equal third side, and we don't here, so that's why they're not similar. And here we're given information here about what is congruent, highlighted in yellow. And then we look at A is congruent to itself, so that's where we get the two angles. And here we're just putting that in the form of a proof. What we're given, the angle A is congruent to itself, and therefore they are similar because of the angle postulate. Here, same, very similar type of thing here, vertical angles happening at C. And then we're given that these are right angles, so we could say that those are congruent to each other. And then now we have two angles, so the angle postulate. And then because of that, we can use and we can set up these ratios. So I put 10 is to 60, as 40 is to we don't know, cross multiply and solve to get the 240 feet. Here we need to make sure that everything is in feet except for the 16 inches, so we convert that to feet. So I keep that as 4/3. So 6 is to 4/3. So the vertical post to the shadow length is to, I don't know, over 122 feet. We cross multiply and solve here. And when we're solving with a fraction, we multiply by its reciprocal. And then here, very similar thing, we're setting up ratios and solving. And when we solve here, we need to FOIL here, so that's where we get our quadratic formula. And then we need to make sure everything goes on one side. Here in this step, I just divided everything by 2, so I'm dealing with smaller numbers, and that allows me to have a 1 in front, which makes it easier to factor. Move the 540 over by subtracting to get here. So you can have two things that you do here. I ended up factoring here, and only my positive answer is what is included, or you can use a quadratic formula.